All right. So I'm going to go over this practice test for Module 7, and hopefully my document camera holds out here. So first question is where we're working on the independent and dependent variables. So remember, the independent variable, that was the input, like what can go in the equation. The dependent variable, that was the output, what came out of the equation. So for this question, they have the table kind of backwards, so that can be a little confusing a little bit. So the dependent variable is that output number, which we've usually had swapped around. So I don't know why on the test it put it this way, but it just did. So here's what it says. A student rents a bike by the hour. Place an X in the appropriate cell to identify the independent and dependent variables. So here are two things. We have the total cost of renting the bike, and that's our variable C. The number of hours that you rent it, they say that's H. So if you think about these two things, remember your output number is like your answer. So if you're thinking, what is the answer I'm getting? Well, that's the cost, right? Your answer is always going to be the cost or the total of something. So the total cost of renting the bike is your output variable. And then the number of hours you rent it is what goes in. So if you were writing an equation, you would say a number times H would equal the cost, okay? So your independent variable is what's going in. Your output is what is the part that's going out, okay? All right. Does number 1 make sense? Do I need to go over that anymore? Okay. If I start doing this on the screen and you guys can't see it, make sure you come off mute and let me know, okay? Because I don't want to be writing and you can't see. All right, so the second one down there, it says a store charges $2.50 for each soda. So we're going to charge $2.50 per soda. The total cost in dollars, C, for the S, sodas, is equivalent to, and here is my equation, 2.5 times S. So that's my rule box that's right here. If I take 2.5 times the input, the number of sodas, my output is going to give me my cost. Just like we talked about in number 1, your cost is usually your output, okay? So this has everything filled in except this last box. So all it wants us to tell is what is the missing value in the output column. So all I have to do is substitute in and actually work out this equation that they already have written. You remember will have your calculators. So you can just type that into your calculator. I know you may not have that at home, but if you have your phone, you can use the calculator that's on there, okay? So we have 2.5 times 3. So that's just what I'm going to type into my calculator. I'm going to type in the 2.5 times 3, and out is going to come 7.5, or in this case, they would owe $7.50. Okay. All right, so this is the input-output table where they gave you the rule. You just were looking for the output number. Okay. Anybody have a question on that one? Okay. Then that takes us to number 3. Oh, I did forget to tell you points on these two. Sorry. So this top one is just a 1-point question. You're going to get a half a point on each. So half a point for a total of a point. And then this one is just a 1-point question as well. So did you just type that in correctly and get the correct answer? Okay. And then down to number 3, this will also be a 1-point question because it's a multiple choice. So it's just, do you select the right answer? So here's what it says. And again, it's an input-output table. It gives you the rule in the middle. On this table, you can probably see the input is missing. It gives you the answer in the rule. So we have to go back and figure out what exactly is going in. And here's our scenario it sets up. Anne has 210 stickers to give to students at school. The number of stickers, T, each student will receive is equal to 210 divided by the number of students. So that's where they came up with this rule box that's right here. 210 divided by the number of students. The input-output table represents this situation. Which number should be entered into the input column, this column over here, in order to complete the table? So when you think about that, 210 divided by S equals whatever this output is. Here's a couple of things we know. The opposite of division is multiplication. So if I take S times T, I'm going to end up with this 210. But I also know because it's division, I can switch up what I'm dividing by. I can divide by the T and get the S. Because remember, these two can go in any order. When I divide, the only thing that's going to be true is the big number has to be my starting spot. Okay? So what I'm going to do is flip these around, and instead of dividing by S, because I don't know what S is, I'm going to try and figure out 15 times what gets me to 210. And a good way to figure this out is take 210 and divide it by 15. And when you plug that into your calculator, you should get a 14 back out. And on this one, I'm going to do the same thing. 210 divided by 10 this time, because 10 is in my output column. I'm going to get a 21. And then this one's going to go 210 divided by 5. And I'm going to get a 42 for the input. So when I look, letter D has those in order. Okay. Anybody have a question on number 3? All right, then we'll just keep going. All right, so number 4, we see our input-output table again. And this time on the input-output table, we're again missing the input. So this feels a lot like number 3, but my equation's a little different. It's not a division equation this time. It's an addition equation. Okay, so let's see what it says. Jose bought a glass of milk for $1.50 and a cupcake that cost cupcakes that cost $1 each. The total cost, T, of the glass of milk and the cupcakes is equal to $1.50 plus C. So that's where they got the rule. Complete the table to find the number of cupcakes purchased for the total cost given. So again, I have to think about what I know about addition. I know if I take 150 plus C, I'm going to get my total cost. They should have put a T here instead of a C because we wouldn't have the same variable twice. So my total cost has got to be the biggest number, right? When I add, my total cost is going to be the biggest number. So this output number is going to be the biggest number. I'm trying to find the missing input number that goes right here. So if I think about what I know about addition, I know it's the opposite of subtraction. So if I take my total cost and I take away this $1.50, I should get how many cupcakes they purchased. Now, the reason that they don't have the times $1 there is because they're just $1. So it just leaves the C there. Okay. So when I plug this in, I'm going to take the $7.50 into my calculator minus the $1.50, and out comes 6. I'm going to take the $9.50 minus the $1.50 they're charging for milk, and out comes 8. $10.50 minus the $1.50 for milk again, and out comes 9. So I'm going to take a look on this one when I grade it and see, did you get these 3 answers? So this is going to be a 1-point problem. Now, if you got 2 of these and you just miss 1 of them, I'll give you half of your points, okay? So it is just 1 point, but I'll give you a couple of points or half of your points if you've done the work, you just miscalculated there. Remember, though, if you're using your calculator, make sure you're typing it in multiple times, okay? So that you have a good way to check yourself and make sure you're sure of your answers. All right, any questions on 4? Okay, then we'll go on to 5 down here, and 5 has 2 parts. There's a part A and a part B, and I'll explain how I'm going to grade this one, but this is a 3-point problem. So this one is worth a lot of your points on your test. It's going to be worth 3 points total, okay?
Miss Hunter?
Yes.
On my screen, I keep on seeing Xander putting weird distracting emojis on my screen.
Okay, let's make sure, Xander, that we're not doing anything that's going to keep somebody from being able to concentrate, okay? Thank you. All right, so here we go. Bonnie has a coupon for $15 off her total purchase at the clothing store. The amount of money owed is the total cost of the purchase minus $15. So her coupon takes away $15. So X is what she pays before her coupon, and then her coupon subtracts $15 for us to figure out how much does she owe altogether. Okay, so we're going to go through and work on how do we figure out the amount owed. So this is just an input-output table. All you're going to do is type into your calculator this value for X into this equation. So you're going to type 37.52, and you're going to subtract her $15 coupon. And you're going to find out that she owes $22.52. She goes to purchase again, and it's a total of $41.55. Take away her $15 coupon, and you get $26.55. And the third purchase, it cost her $45.35. Subtract the $15 coupon, and you find out that she owes $30.35. So this is where I get 1 of your points for this problem. Just that you completed the input-output table, okay? Just that you can type that into your calculator and get the amount she owes after the $15 coupon, okay? Now, part B down there is Bonnie gave the clerk one $20 bill. She got $4.10 back in change. So here's what we've got to think about. She goes to pay her bill. It's 20 with a $20 bill. She gets $4.10 back in change. We're trying to figure out what was the original price that she was trying to purchase. So here's what I think when I see that. I'm going to start with $20. And I'm going to take away the $4.10 she gets in change, because Bonnie didn't spend that amount. She had $20, and this is what she got back in change. So I'm going to figure out how much did she spend out of that $20 bill. And again, you have your calculator for this, or you can do the subtraction if you want to subtract that out. But you'll get that Bonnie was supposed to pay $15.90. Okay, now that's going to get you one more point, because there's a little bit of a trick to this question. It wants to know what was the original price. That means I need to know the price before the coupon. So we've got to think about this. If she paid $15.90, that means she also got to use her coupon. So we've got to add that $15 back on, because she also was supposed to pay $15 more than what she paid, because she had a coupon for this. So when I do the $15.90 plus $15, here's where you get your third point, because you find out her bill was $30.90. Okay, so I can go back and think about it this way. She went to the checkout, and this is how much they would have said she owed. So she gives them her coupon that takes away $15, makes her bill $15.90, and that'll get me to the $30.90 there. Okay, so if you forgot that, you would still get 2 of your 3 points if you forgot to add back on your $15. So, but that one is a 3-point question, because it has 3 different parts you have to do. The table, fill out what did she get for change, or what did she pay after she got her $4.10 in change, and then add her coupon back to that. Okay, are there questions about 5? That would be like an apply question on one of our assignments. Have lots of parts. Okay, then we'll keep going. All right, that takes us to number 6. So now we have an input-output table completely filled out, but we're missing the rule. So that's something that we're going to have to work on here, and that's what our question's going to ask us. So here's what our problem says. Andy works at a store making pies. The table shows the total cost for the pies. That's over here in our output side. That's our dependent variable. And then we're supposed to write an equation to represent the relationship between the cost and the number of pies, which is P. So my cost depends on the number of pies I buy. So when I look at this, remember how we did this. We looked at our table and we saw what was the difference between all these numbers. So when I think about 22 to 44, I'm thinking that's a difference of 22, and I can keep checking. 44 to 66, yep, that's still a difference of 22. 66 to 88, yep, that's a difference of 22. So here's what I know. I'm going to use that 22 because that's how much my cost is changing. Now remember, my cost depends on how many pies I purchase. So I'm going to use the P, my variable for the pies I purchased. So my pies are going to be $22 every pie I purchase, and that'll equal my costs. Now, if this is a one-step equation, then I'm done. And there's a good way to check it. Well, actually, there's two good ways. One, my number that I'm growing by is the same number as my start number, which tells me that's a one-step equation. I can also substitute that 1 in, and I know 1 times 22 is 22, and that's exactly what I was supposed to get back out. So this is all I would need. This is a one-step equation, and once I have it, I get my 1 point for that problem. Be careful on this and make sure you have both variables, okay? If you would leave off your C, I would only give you half of your point for that because half of your equation is missing. You didn't tell me what it would equal. All right. Any questions on that one before we go on to 7?
Could I see it one more time?
Yep. Sorry, sweetheart.
Thank you.
You're welcome. All right. So we're looking at 7, and it looks like the exact same thing. We've got an input-output table, and the number 7 does give us some choices to look at here. So the table shows the number of corn dogs on the trays at the lunchroom. Which of the following two-step equations represents the number of hot dogs? It just changed from hot dogs to corn dogs. Whoops. On the tea trays. All right. So we got to select all that apply. So if I look at this, I know that this is my input and this is my output. So my corn dogs or my hot dogs has got to be my answer, right? So when I look over here, just like I did on the problem up top, I want to see how far away are those output values. So when I look here, there's a difference of 2, there's a difference of 2, there's a difference of 2. So I'm going to use that 2. And I know my trays. So each tray must have 2 of these on there. Okay? But when I look, 2 is not what I was supposed to get in the output column. I was supposed to get a 3. So to get from 2 to 3, I'm going to have to also add 1. Okay? So remember to do that. You can always plug in. We know that 2 times 1 is 2, but I needed, if it was 1 tray, I needed my answer to be 3. So to get to 3, if I was already at 2, I just add 1. And when I look at these equations, the first one is that same equation. And the third one is that same equation. One just has the output answer first, and one has it as my equals. Be careful because I can't combine 2t and a 1 and make 3t, remember? That goes back to a couple modules ago when we talked about combining like terms. I can't combine those because they're not the same. And I can't just leave it as 2t because that would only get me 2 in the output, and I needed a 3. So this is going to be a 2-point question. I'm going to give you 1 point for picking each of these. So 1 point for this one, 1 point for that one. So if you only picked 1, you would only get 1 of your points on that. Okay? All right, questions on number 7. All right, then let's keep going. So number 8. The table shows the total number of treats, T, to feed the dogs, D. Write an equation to represent the relationship between D and T. So again, this whole page has been the same type of problem. They give you the input, they give you the output. You have to come up with that rule. So if I know input is my dogs, output, or the dependent variable, is the number of treats they get, I've got to look at my output and see how much is the difference between those two numbers. So if I look, 4 to 6 is 2, 6 to 8 is 2, 8 to 10 is 2. So I'm going to have to do something with that 2. So 2 times my input. So every dog gets 2 treats. And that's going to tell me how many treats do I need total. But here's what I know. 2 was not what I was supposed to get out. I was supposed to get a 4 out, because when I substitute 1 in, 1 times 2 only gives me 2. So to get from my 2 to my 4, I'm going to have to add 2 on. So my rule would be take 2 times the number of dogs plus 2 more, and that will give you the number of treats that you need. And this is also a 1 point. So just a point for writing your equation correctly. So if you would give me the 2D and not add the 2, I would still give you half your point. You got half the equation right. You're just missing the other half of it. Okay? So be careful and make sure you have all pieces of your equation that you need. All right, so 6, 7, and 8 are actually very similar. Do you guys have any questions on those that we can answer before we go on? All right, I see a lot of thumbs down, so we'll keep going. Almost there. This was a long one. It's got lots of parts. All right, number 9. The table shows the number of dollars Bob and Sally earn in allowance over the past 4 months. If the pattern continues, how much more money will Bob earn than Sally after 10 months? So here's what we know. Bob and Sally are earning the allowance. Here's Bob, here's Sally. I need to know what's going to happen when they get to month 10. Now be careful. Don't continue the pattern and think it goes 1, 2, 3, 4, 10. You're missing a lot of numbers. So the first thing you're going to have to do is find Bob's rule and Sally's rule. And then we can worry about that 10. So let's look at Bob for a minute and pretend that Sally isn't over here. So looking at Bob, I can see the difference between Bob's numbers. Looks like he's growing by 8 every time. So I know Bob's going to grow his allowance by 8 every month. And I guess month could probably just be an M there. It didn't give me a variable. And I know 8 is what I was supposed to get out. So it's just a 1-step equation. And that's going to give me, I'll just use money because it didn't tell me what his allowance is. Or I could use A, I guess, whatever the variable is. So let's think about Bob real quick. If Bob does this for 10 months, he should have $80 then. So that'll be Bob's allowance after 10 months. So I'm going to repeat the same thing for Sally here. So I'm going to look at Sally. She is growing by 5. So it looks like Sally must get $5 a month, and that's her total allowance. So after 10 months of Sally's allowance, Sally would have $50. So Bob has 80, Sally has 50. The next part of my question is how much more does Bob have than Sally? So I would take Bob's 80 minus Sally's 50, and I would get an answer of $30. So this is going to be a 2-point question. And here's how I'm going to get your points. You're going to get 1 point for this, your final answer. And then you're going to get a half point for how much is Bob's allowance after 10 weeks, and a half of a point for how much is Sally's allowance after 10 weeks. So this would be like an apply question that we did in one of our lessons, because it not only just gave you one person, it gave you 2 people. So you just had to do the same thing for both of our people. And then find the difference. All right, any questions on 9? All right, I see a lot of thumbs down. Okay, then I'll keep going. Number 10. This was a 2-part question as well, which means you're going to get a point for each part. 1 point for the table, 1 point for your graph. Okay, so you're going to get 2 points total for number 10. All right. The equation, and it already gives you the rule. I like it when it does that. That's super helpful. S equals 8W represents the hours of sleep, so that's your S, in weeks. So that's your 8. So you get 8 hours of sleep, how many ever weeks you sleep, and it'll tell you your total numbers of hours of sleep. So all we have to do is figure out, what does S equal? Remember, here's our rule. S equals 8W. So all we do is we plug in these values for our W. So we plug in 8 times 1, and we get 8. We plug in 8 times 2, and we get 16. We plug in 8 times 3, and we get 24. So there's 1 point. And I don't care if you write this step out or not. That's like the 3rd column where it gives you the rule in there. If you just can do that in your head and you want to put the 8, 16, and 24, I'm going to count that right, because all it's asking is for the answer on this piece. Okay? Then you're going to come over to your graph and you're going to graph those points. So it says go 1 week over 1, up 8. 2 weeks over 2, up to 16. And this graph isn't quite big enough. It will be on your test. Over 3 up to 24 would probably be somewhere up here. I know this is a 1-step problem that I'm working with, so I also know it has to go through 0, 0. So that'll give me a hint there. And then I'll just connect my line the best I can. Okay? So remember, 1 point comes that you graph these points correctly and connect your line. And 1 point comes that you fill in your table. So you're going to have 2 points on that one. Questions on 10? All right. Then we'll keep going. We got one more graphing question down here on the bottom. Graphs were something that we added after we got our tables all filled out. So number 11, we're supposed to look at the graph and we're supposed to write the equation now. So this is the number of balls of yarn across the bottom. And we know this is always our input. And this is our output that's over here, the number of feet. So this is our output. Okay. Oops, sorry. That looks like an O. All right. So we've got to take a look and see what points we see on our graph. So it looks like this is 0, 0. So if I make an input-output chart input, output. I'm going to guess input. We could use Y for yarn for my input. We could use F for feet for my output, because it really doesn't tell me what I'm supposed to use for my variables there. So as long as you make up your variables and I can tell what they go with, you could have used B for balls of yarn here. That could have worked. Could have used N for numbers of feet there. As long as they go with those, I'm okay with them. All right, so I'm going to look. This point is 0, 0. This point, it goes over one ball of yarn, and up to 36 feet. Okay, I'll look at this next one. It goes over 2 and up to 72. So when I look, I already know it's a one-step equation because it went through 0, 0. And I see that 36 is what I'm growing by. So if I take 36 times the number of balls of yarn, I will get out the number of feet I have. Okay, this is a 1-point problem that you give me this equation. Okay, the way to get this equation is I look at my points that were already graphed, and I'm going to make my input-output table. All right? Any questions on that one? Okay, see a lot of thumbs down. We shouldn't have hearts going up. Thumbs up or thumbs down. All right? Okay, did somebody have a question? I dinged. Okay, then we'll keep going. Number 12. Number 12 says we got a big missing table and a graph. So it looks like I'm going to have to do all the work. This is like when we got to lesson 4 at the end of the unit. So Ken plays in the band. Each week he must practice and prepare 2 new musical pieces. Represent the relationship between the number of weeks, which it tells me is W. So I know that's going to be my input. What goes in? How many weeks do I practice? And then the total pieces, which is going to be my output. So let's think about what the problem tells me. He does 2 musical pieces each week. So I know that his number of pieces is going to be 2 per week. Remember, anytime you hear that per, that tells you that's a multiplication equation. So if I put in, and this is where I can pick my values, I would probably pick 0, 1, 2. If you want to pick 1, 2, 3, I can do that one too. But you only have to pick 3 numbers. So I'm going to plug them into my equation, and I'm going to say 2 times 0. Well, that's just 0. 2 times 1, that's 2. 2 times 2, that's 4. 2 times 3, well, that would give me 6. I don't care if you do 1, 2, 3 or 0, 1, 2, just as long as you pick 3 values to plug into your equation. And again, I got this equation by looking back in my problem. It told me my output is P, so I know that's my answer. And I need to do 2 new musical pieces each week, which tells me take 2 times the number of weeks. Okay, so this is actually going to be 2 points up here because you had to create their whole table. Now your next point, so this is a 3-point problem total, is just that you can graph those points. It's a 1-step equation, so it's going to go through 0, 0, and we're going to graph 1 week, 2 pieces, 2 weeks, 4 pieces. 3 weeks, 6 pieces. Remember, you only have to have 3 points. Once you have your 3 points, go ahead and connect your line. And that'll give you your last point for problem number 12. All right, we got 2 more. Number 13, write the letter of the graph, table, or equation that best represents each situation in the space provided. So what it's asking you to do is A is one of these, B is one of these, C is one of these, and D is one of these. So when I look at my graph, I see there's 1 for every 20. So when I look at my information, this is $5.25, and then look at this one. That's the only one that has a 20 in it. Let's see what it says. Kelly sells 20 cookies each day. So one day, 20 cookies. So letter A matches with this description. This would have a graph. Okay. Now let's look at what I have here. I have 4 days, or D, whatever D stands for, and M. So let me look here at my numbers. This is 6, but it has an M. This is 4. So let's look what it says. Joe ran 4 miles each day. So I would take 4 times the number of days, and I would get how many miles he ran. So B goes here. That one's gone. If I'm looking here, it looks like I'm growing by 6. So 6 must be an important number. Let's see if this one makes sense. Rob ran 6 miles each day. One day, 6 miles. I think that one works there. And letter D. 5 1/4 M. Well, remember, 1/4 is 1/4 or 25 cents. So this one would be letter D. This is going to be a 2-point problem because I'm going to give you a half a point here, half a point here, half a point here, half a point here. Okay, so look at your important numbers, and that's going to give you clues as to which situation these go to. All right, so make sure you check those out. All right, last question, and we will be done with math for today. The owner of an ice cream store is donating $5 plus a portion of today's proceeds to charity. For each cone sold, they donate 50 cents. So this is, again, got a whole table to set up. So this is back to a 3-point problem. You're going to get 2 points for getting your whole table set up and 1 point for graphing it correctly. So let's see if we can get this set up. We know the C is going to be my cones, my ice cream cones. So I can pick 0, 1, 2. You can pick 1, 2, 3, whatever you want to pick. My D is going to be my donations, my output. How much money are they going to donate? And now I've got to come up with my equation. So listen to what it says. The owner of the ice cream store is donating $5 plus. So I know they're going to donate $5 whether they sell an ice cream cone or not. Plus, for each cone they sell, they're donating 50 cents. So every cone they sell, they're donating 50 cents per cone. So they donate $5 plus 50 cents per cone, and that's going to give me their donation amount. Okay? Remember, don't switch these two around because otherwise you're telling $5 per cone and they were only giving 50 cents to start with, which will give you a very different donation amount. So now all we got to do is plug in our values here. So 5 plus 50 cents times 0 if you chose 0, 5 times 50 cents times 1, 5 plus 50 cents times 2, and I'll go ahead and do the 3 as well. You remember only have to do 3 of these. I would do 0, 1, 2 or 1, 2, 3, totally up to you. And then I'm going to fill in the donation amount. So on the first one, they would just donate $5. If nobody buys an ice cream cone, they're going to give $5 that day. If they sell 1 ice cream cone, 5 plus 50 cents, so $5.50. 2 ice cream cones will get them to $6. 3 ice cream cones. And they, since you know the rule, they can continue this on and on and on. And then we could graph it. So 0 ice cream cones, they still do $5. This is not a 0, 0. It doesn't go through the origin because my equation is 2-step. I have to multiply, then add the $5. So then 1 ice cream cone, $1.50. 2 ice cream cones gets me to $6. 3 ice cream cones gets me $6.50, just about halfway there. So I'm going up this way. Okay. And that would be the end of your test. So remember, your test is going to be whenever we get back. Whether we're here tomorrow or not, we'll take our test tomorrow. If we're not here tomorrow, then we'll take our test the next day we're here. You have your point total, but if you add all those up, this test is out of 24 points. Okay, this is a 24-point test. Okay. If you retook your Module 6 test, I didn't get those graded yet. They were left on my desk Friday when I left. So I'll be grading those while you're doing your meet with Miss Riggins, and I'll get those in. Okay? Does anybody have any questions for me for math?
If we need the video, when will you get it posted?
As soon as it sends me the link, Celia, I will get that posted, okay? I'm going to actually stop the recording of it right now, and so it'll start sending it to me. Okay?